Everybody, how are we doing? So today we are going to be continuing our lesson on light. And so for this, you do need to make sure you've got your notes, you've got something to write with, and you are going to need a calculator again. All right, so last session, we talked about using the speed of light formula and how we could use speed of light, and that was equal to our frequency and our wavelength. So we could use that to figure out what the frequency was of a particular wave, or what the wavelength was for a particular wave. So for that energy that we've got there. Now, Planck's energy, or the particle equation, is how we actually figure out the actual value of the energy. So how much energy is actually inside of the wave that we're talking about. Okay. So for this is the equation that we use. We use energy equals Planck's constant times our frequency. So our energy, which is E, equals Planck's constant. Now this is a constant number, just like the speed of light number was a constant number. Planck's constant is a constant as well, and it is equal to 6.63 times 10 to the negative 34th joules times seconds. And then I've also got frequency, which again we can solve for using that other equation that we had earlier. Okay, now since Planck's constant is a constant, we're obviously not going to have to solve for it, just like we weren't going to solve for the speed of light. So you do need to know how to rearrange our equation. First off, with energy, it's obviously just Planck's constant times frequency, right? That's it. But with frequency, we're actually going to have to take and do energy divided by Planck's constant. So this one actually does change up a little bit, unlike the speed of light formula. So how do we do this? Again, it's plugging in your numbers and you're solving. So what is the energy with of the following wave with a frequency of 6.32 times 10 to the 20th hertz? So I know that my energy equals Planck's constant times frequency. So my energy equals 6.63 times 10 to the negative 34th joules times seconds times frequency, which was 6.32 times 10 to the 20th hertz. Now remember, hertz can also be written as s to the negative 1, which could also be written as something over s, right? Okay, so then we can cancel out our 2 seconds, and we're going to be left with joules. Well, joules is good because joules represents our energy. All right, so then I plug it in my calculator, 6.63 times 10 to the negative 34th times 6.32 times 10 to the 20th, and what I'm going to find is that my energy equals 4.19 times 10 to the negative 11th joules. And that's it. That's all you need to do. Okay, so that's all you have to do to solve for this particle equation. So that's my answer. So I want y'all to actually pause your video and actually solve this next problem. Okay, so go ahead and pause the video, solve this next problem, and then we'll actually come back and work it. All right, so hopefully y'all paused the video, so let's actually go over it. So your answer should have ended up being 5.28 times 10 to the 18th, 1 over s, or s to the negative 1, or hertz. Any of those units would have been fine. But how did I get that? So first off, I knew I was solving for frequency. They asked me, what is the frequency of a particle that has the energy of 3.50 times 10 to the negative 15th joules? So I do frequency equals energy over Planck's constant. So I plug in my numbers. So I found that my energy was 3.50 times 10 to the negative 15 joules divided by Planck's constant, which was 6.63 times 10 to the negative 34th joules times seconds. I solve that, and I'll end up with 5.28 times 10 to the 18th, s to the negative 1, 1 over s, hertz, something like that. Okay? All right, very last one. I do want y'all to give this one a try by yourself. This one takes both of those formulas that we've worked with and combines them into one. So pause your video, solve the problem, and then we'll go over it. All right, so here is your problem. So first off, it says, what is the wavelength in nanometers of the following wave with an energy of 7.83 times 10 to the negative 16th joules? So first off, I need to solve for frequency. Why? Because I know that I can take my frequency and solve for my wavelength. So we start with that, solving with frequency. So frequency equals the energy over Planck's constant. And that's what I did with this first section right here. So energy equals, or frequency equals energy over Planck's constant. Then we found that that was 1.18 times 10 to the 18th as our frequency, 1 over s. Then I need to solve for wavelength. Well, I know my formula for wavelength is wavelength equals the speed of light divided by frequency. So that's what I did. I did wavelength equals 3.00 times 10 to the 8th meters per second divided by my frequency, which I just solved for, which was 1.18 times 10 to the 18th, 1 over s. Cancel those 2 seconds out. We're going to end up with meters as our unit. You'll end up with 2.54 times 10 to the negative 10th meters. But then my question asked me to solve for it in nanometers. So I did need to do one more thing and convert from meters into nanometers. And I would use that equation, use my dimensional analysis to convert from meters into nanometers using my 1 times 10 to the 9th nanometers for every 1 meter. And I would end up with 0.254 nanometers as my answer. All right, y'all, that is it. That is all for our notes on electrons and light. Please don't hesitate to reach out if you've got any questions. And y'all have a great rest of the day. Bye, y'all.